Welcome to series of database management system video lectures. Today we will be discussing about unit 3 topic 7.1, that is concurrency control schemes. The second technique, that is timestamp based ordering protocol. Now what is timestamp based ordering protocol? Now, for every transaction, we assign a unique value. In order to identify what is the timestamp for every transaction. Now, what is read timestamp of transaction A, which indicates that what was the time at which the last read operation which was taken place upon A. Then write timestamp upon data member A is nothing but the timestamp at which the write operation which was performed lastly upon data member A. So these are the two technical terms that we need to know. And TS is nothing but timestamp of the transaction TI. There it is T1, T2, T3. So these are the four different things that we use as part of our example. Now let us take an example. T1 is a transaction which has started at 10 o'clock. T2 is a transaction which has started at 10:15 a.m. and this is 10 a.m. right? So now I wanted to perform a read operation upon data member A, right? So now as T1 was started very firstly, so let me assign a unique value, that is 10 to T1 transaction. So this T1 transaction is called as oldest transaction or old transaction. Now the second transaction which has taken place at 10:15 a.m. Delayed by 15 minutes. So even this is attempting to perform read operation upon data member A. Compared to T1, T2 is younger transaction, right? So now the third one is T3 transaction, which has started by 10:25 a.m. Now for T2 transaction, I need to assign a unique value which should be larger than T1. Okay, so that's how I have assigned 20. Now T3 has to start. So T3 value should be assigned compared to T2. So I have assigned 30 to T3. And even this T3 transaction wanted to perform read operation upon data member A. So this is going to be youngest compared to all the three transactions. Now, if a question is asked, what is timestamp of read transaction upon data member A? So we need to give the value as what we have three different values. So we need to consider only the youngest value, that is 30. So the timestamp of read transaction of a variable will be 30. Okay. So we need to always consider the youngest values only. Now, once the youngest transactions operations are done at later point of time, if older transactions wanted to continue to perform changes, then it should not be allowed. Why this sort of thing should be allowed? Should not be allowed here is to maintain consistency of the database system. We should not allow any changes to the data which has been read by the other transactions. Right? Now, let us take another example. Now, T1, T2, and T3 are three different transactions. Now, T1 has started write operation upon data member A. Now, I have assigned unique value 10 here. And then T3 has started write operation upon data member A. So we have assigned 20 to T3 transaction. And then T2 transaction has performed write operation upon data member A, to which value 30 was assigned. Now, by looking at this schedule, what will be the write timestamp upon data member A? So, we have three different values. We should consider only the operation which has done lastly. So, T2 was the operation which has taken lastly. So, the timestamp of that is 30. So, we need to consider the write timestamp will be 30 here. Okay. Let us look at the rules which have to be followed for timestamp protocol. Yeah. So these are the rules which have to be followed. So the first one is that transaction TI issues a read operation. Then we should check whether write transaction, write timestamp upon A, if it is greater than timestamp of I, that is whether T1, T2, T3. In that case, you should roll back that transaction. So depending upon the scenario, either we need to perform a rollback or not. The second option is that if this condition was not satisfied, then we need to set up the write timestamp upon variable A, which can be taken as the maximum of both read timestamp upon variable A and timestamp of a transaction TI, right? So after setting up this, we need to get into write operation. When read operation is performing, we need to check both A and B. When write operation is performing, then we need to check both A and B options. So here for write operation, if read timestamp upon a variable is greater than the timestamp of ti, then we need to perform rollback, or otherwise we need not. If write timestamp upon a variable is greater than timestamp of ti, then we need to perform rollback operation. If both the conditions are not done, then otherwise we need to execute write operation upon a variable, and we need to set up the value to the write timestamp value as the last transaction number, right? So now why this sort of rules which have to be considered here? In order to overcome with the drawbacks which we have already come across with the deadlock scenario, and then to maintain a consistency of the database and to always bring down the schedule into a serializable schedule, and to recover from one particular point, from one particular unsafe state to a safe state, it is suggested that we need to follow the timestamp based protocol concept, so that we will be able to decide what was the last operation which has to be considered. Okay, so whenever you are performing read operation, we need to follow A and B options. When we are performing write operation, we need to follow this ABC options. Now, at what scenario these set of operations have to be done? When you are performing read operation, what will be the conflicting operation to the read? That is write. So that's the reason we are checking upon write timestamp of variable A. Similarly, when you are performing, that's the reason we have only one checkpoint here. Now, with respect to the second one, where we need to look at write operation. So for write operation, we have two conflicting operations. One is read timestamp and the second one is write timestamp upon the same data member A. Okay. So this we need to understand by taking with an example. The third type of transaction control scheme or the protocol is multi-version concurrency control protocol. So in this multi-version concurrency control protocol, now we have a data item. Now, this data item can be shareable by multiple number of processes or multiple number of people by different set of transactions. So now here, let us say that P1 is one person, P2 is another person, and P3 is another person. Now P1 process attempting to access to the data. Now you will get one copy of it. One version of data is going to be read, and if you wanted to perform any kind of write operations also, it can be allowed. So this copy is maintained with respect to P1 person or P1 process only. Now the second user has access to the same data. So now the copy of the data can be given to it. So this is going to be taken as the second version of data. So even here, P2 process will perform read operation and write operation upon that data value. And then P3 is another process which will also gain accessibility to the same data item but with a different copy. So even here, read and write operations can be done. So in this manner, at a different time stamp, at a different time stamp, different set of processes are going to access to the data. So unlike going with the locking mechanism wherein it is going to perform a tedious job for accessing, obtaining, and then releasing the logs, and that's how entering into a deadlock state or starvation, and we will not be able to resolve that issue, right? So instead of performing all that set of operations, we are just trying to give a different set of copies of data to it. Now, in this multi-version concurrency control, whatever may be the version of data which has been obtained at last will be going to be freezed. So here, any operation which is done by the data item at finally is going to be taken into the consideration. Now, if P1 changes wanted to be restored, then you need to perform a commit operation. Now here, the database changes should be accepted. Now, while doing that saving into the database, it has to check against to the conflicts. If any other conflicts are happening with respect to the other processes, then either it has to perform a rollback operation or it has to uh, stop the other set of operations to be continuing with the changes, right? So we can apply any other transaction control mechanisms which we have discussed earlier depending upon a different set of systems. Okay, so first version of data have to be saved into the database. Second version of data have to be saved into the database. So with these two versions of the data, if there are no conflicts, fine. The latest version of the data can be stored into the database. Now compared to P2 and then P3, if there are conflicting operations, it can be resolved either by rollbacking or committing to that desired point. So with this multi-version concurrency control protocol, the system has upgraded itself by allowing multiple number of users with a multiple number of changes to the data item. Now moving on to the next one, that is fourth one, a validation concurrency control protocol. So in this validation concurrency control protocol, this can also be considered as the optimistic concurrency control protocol. Even the previous one is also taken as the optimistic concurrency control protocol, wherein we are not going to prevent any accessibility to the data items, and that's how we are not going to lock the data items. Instead, we will wait till all the operations are done, and only at during the commit state, we are going to perform the verification of the data items. Now, the same thing is going to be happen in validation concurrency control protocol. So the first one is that we try to read the data which is available to it. And then while performing writing operation, we need to check whether the user have been given with proper privileges to perform changes to the actual database. So reading can be done parallelly to multiple number of data items or multiple number of users. But then when it has to perform write operations, which has to reflect in the original database, so we need to check whether is the person the authorized user to perform the operation, or the write and then read operations where conflicting or non-conflicting operations have to be verified against to the data which is being stored. If that is so, if all the other validation process have been verified as per the asset properties, then you will be allowed to perform any changes in the database at the write phase, wherein the actual data values can be manipulated. So finally, it is going to be freezed so that any other changes cannot be entertained, and this modified version of copy can be released to the next set of users, right? So in this context, you will be able to manage multiple number of users given access to multiple number of data items. That's how maintaining an individual copy to everyone. And if any changes have to be restored, and we need to perform a commit operation, and only then the data can be reflected back into the database, right? So in validation, the most important part is that validation phase is the important part, wherein the decision should be taken whether it has to be either rollback or to commit further to freeze the changes which have been done to the data, right? So this is the end of concurrency control transaction schemes or the protocols. So on the whole, we have four. Okay, thank you.